All right. Um, Hello, everyone. My name is Naheem Noah, and I'm a second-year PhD student at the University of Denver. Today, I'll be talking about our work in progress, titled Optimizing Shoulder Softening Resistance in Augmented and Virtual Reality. This is a replication study proposal in the United States. So yesterday we had a mirror. They spoke about their work where they were looking at the experiences teenagers were having in social VR. In our work, we were more concerned about security in augmented and virtual reality. And a previous work that we've done is that we evaluated the technologies, the AR, VR devices that are commonly used across industries. And we realized that the most common form of authentication is PIN and password. And the problem about PIN and password is that they are liable to shoulder soften attack. And not just that, in the virtual environment, it's actually very hard for users to be able to put in the password because they need to have a whole keyboard in the virtual environment and start clicking on the keypad one after the other. And we also realized that the other form of authentication that's common in AR/VR devices is biometrics. And the problem with biometrics is that there's a lot of data collection, and not just that, it is liable to spoofing attack. So we went on to perform systemization of knowledge and knowledge-based authentication research. And we found out that most research performing a lot of usability evaluations, and only few research are performing security evaluation. And even fewer research were performing both usability and security. So we proposed the theme scheme. This theme scheme, we believe it's user-friendly and is also has high security prospects. So this scheme was first proposed by Meyer et al. In their work when they found out that the theme scheme was more performing than the traditional PIN and password, especially in terms of memorability. So this is like a study protocol that shows how we want to bring about the theme scheme in our study. But I'll focus on the enrollment and the authentication aspect of things. So for the enrollment, what we do is that, firstly, we randomly assign users 5 images at random to be their password. So when we assign them those 5 images at the point of authentication, provide 5 different screens. So these 5 different screens, each screen has 16-grid image. Now, what the user has to do to authenticate, they need to select one image out of the other distractors in each 16-grid image. They select one image on the first screen and move on to the next screen, and they do that for the 5 screens. And that basically, after that, they get feedback if the authentication was successful or wasn't successful. So like I said, this is a cross-cultural study. The primary study was done by our collaborators in Germany, where they focus on AR using the HoloLens. In our work, we're going to focus on both AR and VR using HoloLens and Valve Index. Also, we are going to be measuring the effectiveness of this scheme, looking at how many authentications were correctly done from the number of trials that was performed. We're also going to be looking at the efficiency of this scheme based on the average time taken to perform authentication. Apart from that, we're also going to be looking at the authentication workload using the NASA tax load index. We're also going to be looking at the satisfaction of the users using the system usability scale. And we're also going to measure the resistance of this scheme against shoulder softening attack by looking at the attack success rate. Now, the reason why the theme scheme is different is that, firstly, this is a graphical knowledge-based scheme, which means that not a lot of data needs to be collected like we have in biometrics, right? And another reason is that it relies on visual information instead of text. So users just need to like select the right image out of the other distractors. And this scheme is also based on recognition and not recall, meaning that users just need to recognize this image. They don't need to recall it. And lastly, we believe this scheme is highly resistant to shoulder surfing attack, especially because of the virtual environment that is provided by these technologies. Thank you.
Thank you so much.